looking at this question properly, then let's make sure we see all the details. Barium chloride, there's the formula, is soluble in water, clue there. Compare the electrical conductivities of solid and aqueous barium chloride. Explain your answer in terms of the particles involved. So our model answer needs to tell us that when it's solid it doesn't conduct, and when it's aqueous it does conduct. But we need to explain both of those, and we need to do it in terms of particles. So the top one has got, when solid it does not conduct because the ions are fixed in the lattice, and when aqueous it does conduct because the ions are mobile, or the ions can move. Don't use the term free here. Although it won't lose your marks, it doesn't gain you any marks. Free just means it's not attached. It doesn't give any indication that it might be moving. So, part dotted 2. So we want to use the barium chloride. So it's used to test sulfate ions, SO42-. If sulfate's present, you get the white precipitate. So say both parts of that. You can write this just as sulfate, or you can write it as SO42-. If you give the formula, get it right. Otherwise you might lose a mark if that formula is incorrect. In dotty 3 then, we're going to a calculation. We can see straight away as we glance at it, we've got something to do with water crystallization here. So it's hydrated barium chloride. It's got this formula, and it's the X here that we don't know, and it's got a molar mass of this. We want to determine X. So let's just make sure we always write down everything we know and keep this nice and structured for the examiner to see our thought processes. So we've got barium chloride XH2O has got a mass of that. That has got a mass of that plus 2 of those, which gives you a mass of that. So if we subtract the mass of this from here, we're left with the XH2O. And since that's XH2O, if we divide it by 18, we get an answer of 2. In part C then, electronic configuration of the nitride. You might want to start just with nitrogen itself, just confirm with yourself at the side what we've got for nitrogen, and then it's nitride, so it's going to pick up all the rest of the electrons in that P subshell, so 1s2, 2s2, 2p6. This is probably the trickiest in a way out of all of these. So we've got solid barium nitride is reacted with water, forming an alkali solution of A and an alkali gas. Identify A and B. Then write an equation including state symbols. So let's take a look. First of all, I would have begun with barium nitride up here and just said we've got group 2, so 2 plus, nitride is 3 minus. Remember, you can cross those over and you get to that as your formula for it. So identifying A and B, probably that I would go on to B first of all. It's an alkaline gas. I only know one, it's ammonia. Alkaline solution means it contains OH ions. And since we've used the nitrogen for the other part, this is barium hydroxide here with that formula. Remembering it's group 2, so it's going to have 2 of those. So having got all my formula, we can put an equation together. So we've got the right equation for that. We were told it was solid up here. We've got water, which we know is liquid. We will put in that it's barium hydroxide we're making and ammonia. So when I came to balance this one, I would have balanced it with 3 in front of the barium first, 2 in front of the ammonia first, and then I looked to see that I'd got 6 oxygens here, so I was going to need 6 waters here. Finally, just to make sure no mistakes were made, I would have taken that and said, well, I've got 12 hydrogens there. Does that match? I've got 2 times 3 is 6 there, and I've got 2 times 3 is 6 there. So yes, it matches.